Welcome. Today's lesson is on solutions and the importance of pH in hydroponic systems. To get this lesson started, I'd like to talk about solutions. And solutions basically have two parts, solutes and solvents. I'd like to start off by talking about solutes first. All of these are most of the solutes that we're going to be needing to be able to provide enough nutrients for plants like these hydroponic tomatoes. In order for us to be able to keep all of these alive and growing, we're going to need those solutes. The solutes that we have, and there's all different kinds of them out there. I happen to use this one from General Organics. And how we actually started with these guys is we used some actually Miracle-Gro mixed with this BioThrive. This particular one, as you can notice on the label, it has 4% nitrogen, 3% phosphorus, and 3% potassium. That just wasn't enough to kind of get them started to be able to build the tissues they needed to be able to get nice and large. So I added some of this to the mix as well. And each company sells you, kind of sends you their recipes. So I mixed these two together to really make about a 26 to 11 to, I believe it was something like 12 or 16%. So that gave them plenty of nutrients to be able to grow as big as they are. Now, once this is kind of the growing phase, the next phase we need to consider ourselves with is when it's time to start blooming. And as you saw briefly, and I'll show you a little bit later, they need kind of a special nutrients to do that. Kind of have to lower their, and for a time I'm using both of these. Because I do need a little bit more nitrogen than this, but all I need really for root development and flower development is some of this, and we got to move on to it. And especially for tomatoes, they're going to need some calcium, they're going to need magnesium and iron to be able to actually put out the fruit. Just to show you a little bit of basically what happens if you don't get enough calcium is stuff like this. This is blossom end rot. If you don't have enough calcium, it kind of shuts down the production of making cell walls at the very end of the blossom, and then it rots out like that. So we wanted to be able to get away from that. So we use CalMag or anything that has calcium, magnesium, and iron in it. And how do I know that they're getting it? Well, I also test the tissues on, of course, on the flower, on the leaves. I have a test kit that would do that. But really, if you have enough, these leaves are going to stay nice and green. If you don't, they start turning yellow and chlorotic. That means around the midrib, there's going to be a yellowing. But I also test them in our kit. To hold the solvents and the solutes together, we have some kind of reservoir, and that reservoir is about, I don't know, somewhere between 18 to 20 gallons, and we have a larger one that's 28 gallons. But the one I'm going to show you has about 20 gallons in it that we need to kind of... Here's that one reservoir that's really working these 6 plants as well as those strawberries right there. So this is where all the solvent is. And normally I would have a lid on top of it. It cuts down on the evaporation, but I like to keep it off in the morning because it's nice and cool so that it doesn't heat up. It has to be aerated as well to improve root growth, but also prevent any kind of organic material that's in some of our solutes to break down and, of course, starting to rot, and we don't want that in the smell. But anyway, this water is really important for our solutes, and in particular, I have to always keep it monitored for the pH. Now let's go over to the table, and I want to show you how I actually take the pH readings. Now, there are 2 different kind of ways, actually more than that, but 2 ways that I try. When I'm in a big hurry, I'll be using some of this stuff right here. And this is just a quick and dirty way to get an idea. It's not very accurate, though. I fill this up with water from the reserve tanks, and then what I do is I put 2 or 3 drops in this, and then what I do is I just compare the colors on this, and it tells me approximately kind of what pH I'm dealing with. Again, if you haven't had a bit of a problem and you haven't changed the nutrients out for a while, this one's not too bad. But sometimes you have to add either up or down. There was a time when we were running really acidic because I was running a lot of different kinds of materials that were more granulated than some of these organics that I'm currently using right now. So on this particular one right here, this actually brings down or make it more acidic. I don't want that. Where I really want, most of the time I was using this because I always had to bring it up because it was so acidic. So those are how you do it. Now another way to do it is using electronics. These digital devices right here, and I'll put a link on down below as far as all the stuff that I'm using. But essentially I'm taking a pH and of course the conductivity. What the conductivity sensor does for me, it keeps track of the minerals and salts that are actually are on these solutes that kind of keep things active and alive. So each of these has a recipe I need to follow, and in this particular case, if I get anywhere at this time, because they're sending fruit now, between 500 and 600 parts per million of these chemicals. So what we're going to do right now is we're going to go back over here now. We're going to go back over the reservoir and we will take some readings of pH and conductivity. Alright, we're at the reservoir right now, and now I have two other reservoirs I do this to. But basically I'm taking this pH monitor, actually sensor, and also I'm using this right here, which happens to be a conductivity sensor as well. I just go ahead and put this in like this, swish it around. Now really what this is operated by Bluetooth, so I have an app on the phone that's reading this. And right now it looks like it's about 6.5, and so that's really what my reading is correct. It's kind of going back and forth, and it looks like 6.59, 6.6, and that's where it's kind of, and really what I need for this is a pH that's between 6.5 and 7.5. So that one's taken care of. This is in pretty good shape. Now on this one right here, I look at it and it's milligrams per liter. And it's saying it's about 1,096. And basically milligrams per liter is about twice as much as parts per million. So you just cut that in half, which is about 550 parts per million. So it's in that range of 500 to 600 parts per million in terms of the minerals that are in it. And now what I would like to talk about is what does that range do for us? That 6.5 to 7.5 range of pH, what does it do to us, actually the plants, and why is that important? The reason that we need to know about pH and manage it well is depicted in this particular table. If you see all of these, each one of those lines, it represents a nutrient: nitrogen, phosphorus, potassium, sulfur. Those are all nutrients that are important to plants. And if you notice, the bigger or the fatter each of those lines are, means that's how much more nutrients is being taken up. So 6.5 to 7.5 is kind of the sweet spot where most of all of the nutrients that plants needs will uptake them. Now, one of the important parts that you need to understand, that if you keep that and manage your pH in these systems, you'll get, first of all, a little bit more bang for your buck. What I mean by that is they're taking up at the maximum levels to save you money and, of course, keep the plants healthy. So that's why it's important, because number one, it helps you control the bottom line, which is money, and the second of all, you're giving the plants what they need when they need it. In order to grow tomatoes like this and other crops in a hydroponic system, you have to be really on top of why pH does what it does. If we're not in that range of whatever this tomatoes happens to be, 6.5 to 7.5, then we're not going to grow them very large, very healthy, and of course the health in these fruit is how the plant actually does. So knowing the pH and keep it within that range will allow you to manage all of those solutes in a very precise fashion. I hope this video has helped you, and I'll be seeing you later in the greenhouse. Thanks for watching, and my friends keep telling me, always say, like and subscribe. Thanks. See you later. Bye.